And as of today, I will explain on photomagnetic as well as enzyme responsive polymer. So when we talk about photo, actually, it's not the photo that going to be taken, but actually it is responsive towards the presence of lights. Okay, so that means if these polymers, this photoresponsive polymer or PRP, if they exposed to light, okay, so two changes can occur, two changes of properties, either in the molecular level or in the macroscopic level. Okay, at molecular level, the changes can include conformation, okay, change in charge, chirality, as well as conjugation. For macroscopic properties, it can, okay, very clear now. Okay, thank you. So for macroscopic properties, it can be due to shape change, okay, or wettability, solubility, as well as optical properties. Okay, and the advantage of using PRP is the stimulus can be localized more accurately and specifically. Okay, so I will show you in a while why we say that PRP is more specific, and also actually it can be triggered from outside the system, and that means we can use for non-contact remote applications. Okay, because you don't need to have the temperature or pH inside the system to trigger the changes. Okay, so you can remote this from outside the system also. Okay, because and also actually for photoresponsive polymer, it is good for material that has sensitive towards heat. Okay, some material is very sensitive towards heat and towards pH. Okay, so if you change pH, what happens is that the material will be degraded. So that's why photoresponsive polymer is having advantage compared to pH and also temperature responsive. Okay, so for temperature responsive, actually, how can you change or control? It depends on the parameters of the irradiation, okay, such as light intensity, and also wavelength, and also irradiation time. Okay, so I hope you remember about this, because we are going to test you in a short while. Okay, then okay, next, what makes this photoresponsive, what is the composition of this photoresponsive polymer? Okay, so the photoresponsive polymer consists of course, polymer chain. Okay, what else? So last time, you know, when we see polynipalm, because of its functional group, that can show you this temperature responsive behavior. Okay, so for photoresponsive, actually you can prepare the polymer chain and you can incorporate the chromophore group in the polymer chain. So what is chromophore? Chromophore is actually the compound that can absorb light and activates a chemical transformation, in which it subsequently controls the conformation and also assembly of the surrounding molecules. Okay, so now you can also have another composition. Okay, so the first composition is of course the basic one, when you have polymer chain and chromophore. So because this chromophore can absorb light, so it activates the changes. Okay, and secondly, you can also have polymer chain plus photoreceptor. Photoreceptor is also a chromophore group. Okay, but you can also have additional second functional element. Okay, second functional element. So for instance, when this compound absorb the light, and convert to physical chemical signal. And then maybe the polymer will swell or shrink. Okay, so this is the second functional element. So this is optional. Okay, sometimes it is only up to the chromophore group, but sometimes it is until the second functional element. Okay, now what is the function of the photoreceptor? It is to capture and absorb light that convert this into the chemical or physical signal. And the second element is to sense this signal and give new output function. Okay, so let us see on the chemistry of this photoresponsive polymer, or the properties of this photoreceptor or the chromic compound just now. Okay, so these are typical chromic compound. So if you closely look, you boleh nampak structure dia macam mana. So what kind of structure that you see from this compound? So anyone want to try to give a guess? What about the structure of this chromic compound? Anyone? So, selalu saya kena sebut nama you all. Okay lah. Izlan. Izlan, are you there?
Yes, Doctor.
Okay. So, if you see this compound, what are similarity? Kalau kita tengok this compound. Structure, in terms of structure.
Presence of nitrogen atom.
Nitrogen, tapi ada yang tak ada nitrogen kan? Oh, semua ada nitrogen, okay. Not that accurate. Thank you, Izlan. Any other person want to try? Intan?
Hello.
Ya.
Semua ada benzene ring. Lepas tu dia macam nested.
Okay. Thank you. Thank you, Intan. Okay, because here you see that the presence of benzene ring structure. Okay. So benzene ring structure, kalau if you still remember your organic chemistry, so I'm not going to teach the organic chemistry here. Nanti pengsan pula semua orang. Okay, because there will be a pi-pi interaction kan. So there will be a conjugation, non-conjugation from the electron between this aromatic group. Okay, so that's why this kind of structure usually possess the chromic characteristic. Okay, dia ada chromic characteristic. So for the first one, azobenzene, spiropyranes, spirooxazines, okay, these three photochromic compounds are reversible type. Okay, because we also have irreversible type. Reversible means when you expose to UV, for instance, azobenzene can change its structure from trans to cis conformation. Okay, so yang ni lah trans to cis conformation. Okay, dia boleh switch, dia boleh interconvert the structure from trans to cis. So since this is reversible, so bila you remove the UV light, okay, you expose to visible light, then it can change back from the cis to trans. Okay, untuk spiropyranes dengan spirooxazanes ni, dia change from open to closed structure. So of course, only upon light excitation. Kalau you tak add specific wavelength. So yang ni saya tak letak lah wavelength dia berapa. If you are interested, you can have a look lah dekat literature. What are the wavelength. So that means kalau the wavelength is 360, baru dia specific can occur at 360. If you shine UV light at 400 nanometer, nothing will change because this photochromic is only specific responsive at certain specific wavelength. Okay. Alright. So just now yang ni reversible. And then you can also have compounds yang irreversible. Okay, so ingat sebab kejap lagi ada quiz kan. Kat sini yang contoh yang reversible, azobenzene, spiropyrenes, spirooxygenes. Okay, yang irreversible we can have nitrobenzyl. Okay, so if you see, you have only one arrow, one direction of the arrow. Okay, it will not go back. Okay, so when you expose to UV light source, there will be a cleave from these halides. Okay, so bila ada cleave, so halides ni ada dekat sini and form new structure, and this structure will be maintained, will be the final product. They cannot be switched back to the original conformation or original structure. So same for coumarin, pyrenyl methyl, and also apa ni panjang sangat nama dia. So all these four show only one direction of responsive behavior. So kalau one direction only, that means this kind of compounds is irreversible. Okay. So if you still remember just now, saya ada mention for the adakah this material yang kita perlukan untuk to produce the photoresponsive polymer? The answer is yes. But if you still remember yang bulat-bulat tadi, you have, in order to produce the photoresponsive polymer, okay, of course you need the polymer plus this chromophore atau chromophore. Maksudnya you mesti ada this compound plus polymer. So what you see here is actually only the compound, not without the polymer yet. Okay, so sama je yang irreversible ke ataupun yang reversible tadi, this is only the compound. Okay, only the compound, not the polymer yet. Okay, alright. So here are the polymer. Okay, so now here are the polymer. Here are the polymer containing polymer group in main chain, on terminal groups ataupun side groups. Okay, of course saya tak minta lah you lukis structure ni sebab it's quite complicated, right? Of course, kalau saya nak suruh you lukis, I can ask you to draw, but I will not ask you to memorize, okay? Sebab to memorize each and every inch of the chemical structure will be quite difficult for you because this is quite complex chemical structure. But what I am going to do here is actually to make some differentiation ataupun I want you to be able to classify yang mana satukah polymer PRP yang consist in main chain ataupun in terminal groups ataupun as side groups. Okay. Now, if we look at here, we have A, B, C, D, E, F, G sampai H. Okay. We can start with A. Right. So, kalau you tengok A, okay, if you still remember last time, kita ada ethylene. Okay, so I can draw the ethylene monomer. So this is ethylene monomer, CH2, CH2. So ethylene can be converted into polyethylene. So polyethylene adalah CH2, CH2. So kita ada N kat sini. Okay. So from here we see that this is the main chain lah, ataupun saya boleh tulis CH2, CH, lagi satu H kat sini kan. Okay. So that means here it shows that H ni adalah the macam side group that attached to this ethylene. Okay, because let's say if I want to make so this is polyethylene. Okay, let's say if I want to make PVC, which is polyvinyl chloride. So what I do is I change this side group. Okay, yang ni yang kita panggil side group. Okay, I change this side group to Cl. So I can get something look like this. CH2, CH, so N repeating group, and then Cl. So yang ni adalah PVC, polyvinyl chloride, because we have chlorine as the side group. Okay, so what I want you to do, have a look at this structure, and then from this structure, yang mana satukah yang polymer yang containing chromophore in its side group? So A ke, B ke, C ke, ataupun H ke? Okay. So please have a look. Maybe I can call one of your name. Okay, sekejap saya nak cari siapa ni. Okay. Ong Minbo ada?
Yes, doctor.
Yes, okay. Alright. Ong, Minbo lah sebab banyak Ong kat sini kan. Minbo, which one do you think is polymer having the chromophore in its side group? Give one pun okay.
I think A.
A. Okay, kalau A salah, because A, if you see here, A, the chromophore itself is the main chain. Sebab chromophore ni dekat sini kan, yang ada this benzene ring group, and then dia ada N kat sini. Okay. So anyway, thank you Minbo. So A supposedly adalah yang kategori under kategori main chain. Okay. So that's how you differentiate ataupun distinguish. Okay, another polymer responsive that contain polymer groups in its main chain. Kat mana lagi? You boleh tengok. A dengan which one? Okay. So yang mana yang ada N, chromophores ni, and then ada N repeating group in that chromophores, that shows that that polymer has the chromophores. Sini ada tertinggal, polymer chromophores in its main chain. Cool. Okay. So maybe I ask another student. Ini dia. Ada Najwa tak?
Ya doktor.
Okay. So Najwa, which one? Kita ada A yang main chain, lagi satu yang ada satu yang polymer responsive yang ada chromophores dalam dia punya main chain. Which one? H. Correct. Okay, because dia ada N repeating group dekat sini. Okay. So now you know already. Ada lagi tak yang lain?
Saya rasa tak ada.
Tak ada. Okay. Thank you Najwa. So, okay, Najwa is correct. And then tadi ingat tak yang saya cakap which one is the polymer that contain chromophores inside group? Okay, let's say yang paling senang nak tengok adalah yang macam ni lah. Okay, yang paling senang nak tengok yang macam ni lah. Dia ada CH, dia ada CH, and then kat sini adalah dia punya chromophores group. So sini N. Okay, sini side group kita panggil. So this is side group. So yang mana satu yang ada side group? So anyone want to try?
C, doktor.
C. Betul. Okay. So C, this one kan? Okay. Correct. Ada lagi tak?
E.
Ya, E. Okay. E ni special. Sebab apa saya kata dia special? E ni betul juga. Sebab apa saya cakap dia special? E dengan D. Sebab apa saya cakap E dengan D ni special?
Ada dua.
Dia ada dua, betul. Okay, dia ada dua functional group. Okay, so yang ni, kalau yang ni you tengok COOH kan? Ni ada COOH. Kalau COOH adalah acidic group kan? So kalau COOH, sama macam ni lah. Sebab you gantikan Cl ni dengan COOH, so it becomes this monomer adalah, this polymer adalah polyacrylic acid. Okay, and then kalau yang E ni, kalau you still remember yesterday punya video lecture, PDMA, EMA. Okay, kalau you tak ingat tak apa, nanti you boleh check balik. Okay, so that's why D dengan E ni special, tapi ada lagi satu super special. Ada lagi satu super special. Satu-satunya yang paling special. So, which one? Anyone want to try? Okay, sebab dia ada dua functional groups juga. Anyone? Tak ada
F ke doktor?
Okay. F. Okay. Sebab dia punya structure can form cross-linking. Okay. So nanti saya akan explain lagi on the cross-linking ni. Masa I explain on the synthesis. But as for now, F ni dia ada cross-linking structure. Okay. So, yang ni apa yang saya explain tadi lah. So when you read so I don't need to read anymore. So what is very important untuk photoresponsive polymer adalah, if you want to design the application, you have to consider the type and response. Okay, so for instance, kalau you nak buat drug delivery, okay, drug delivery, usually you guna compound yang you boleh incorporate dalam polymer tu, compound yang irreversible. Okay, that means, so let's say you ada drugs dalam ni, dalam your polymer, and then bila this polymer degrade, dia akan open, so drugs ni akan release. Okay, so kita tak nak dia close balik kan, sebab kita nak dia pecah je supaya drugs ni can release. Okay, so another application, so you boleh think of what are kind of application where you need a reversible reversible response. Okay, untuk yang reversible response you have azobenzenes, dan untuk yang irreversible punya response you have nitrobenzene compound. Okay, alright, and also yang saya cakap tadi sama jugalah, yang how you design your photoresponsive polymer ni, dia depend sama ada you incorporatekan that chromophores, okay, you incorporatekan that chromophores as a main chain, terminal group ataupun side group. Okay, alright, so if you still remember, so this is the electromagnetic wavelength. Electromagnetic wavelength. Okay. So yang tadi yang kita cakap tu memang spesifik lah. Alright. So some compound only works below 400 and some compounds works between visible light spectrum. Okay. 400 to 700. Okay. So as a photochemistry, kalau you memang deal with photochemistry, so this range supposedly you can remember already. Okay, so 400 is UV, 400 to 700 is visible light. Okay, alright. So here are other application ataupun mechanism. So yang macam tadi kita kata dia irreversible dengan reversible kan. So these two application yang irreversible. So that means once you expose to UV light, which is lambda here, wavelength. So this micelle, so nanti you boleh tengok lah micelle tu apa. This micelle will degrade ataupun break. Okay. So yang reversible, this one, these two. Okay, so these two. So key point dia adalah you have to look at the arrow. Kalau arrow dia ada two directions, so it is reversible. So that means here in this case, when you shine the UV light, the structure will be cross-linked. Okay, and when you remove the UV light, the structure can de-cross-link. Okay, sama juga dengan side groups. Okay, so micelle ni akan remove. Bila dia remove, so I hope you know what is micelle. So when it remove, that's why lah some solution dia ada phase separation when you remove micelle. Okay, so ni just an explanation what is micelle. I hope you know what is the micelle. So micelle dia ada actually macam emulsion kan. Dia ada emulsion, contohnya oil in water ataupun water in oil, yang mana you have head and tail kat sini. Okay, so these are the example. So saya maybe boleh tunjuk lah example on micelle. So tadi tu maybe you tengok belah kiri dulu. Saya tak tahu macam mana nak stop kan. Okay, kalau stop dua-dua pula. Okay, tengok yang sebelah kiri dulu. Nampak tak small parts tu dia combine to form a bigger hexagon or octagon. Okay, so yang ni kita panggil self assembly. Selalunya micelles ni formation of micelles adalah self assembly. So this self assemble because of the interaction. Okay, bila you ada interaction, then dia boleh form the self assembly micelle structure. So kalau dia form self-assembly micelle structure, so you can imagine kalau ada drugs, drugs tu akan encapsulate dalam this big balls. Okay, alright. So if you look at your right hand pula, so micelles ni dia boleh, kalau dia deform, maksudnya dia akan buka macam tadi. Okay, sebab dia depends on interaction. And then kalau dia tutup, dia akan form micelle yang macam ni. So dia akan disperse in the solution. Okay, so I give you the link here if you want to know more about micelles and self-assembly. I'm not going to explain about that because I want to focus more on the photoresponsive polymer. Okay, so these are the applications. So usually for drug delivery, okay, sebab drugs tadi can be encapsulated during the self-assembly, okay, and then when you expose the self-assembly structure, dia akan releasekan the drugs. Okay, alright. So these are also the polymer yang mana okay, this one, that's why saya kata dia specific. So that this one dia tak guna UV because the wavelength is quite large, so it is a laser type. So when you expose this to UV, apa yang berlaku? Cleavage of this esters of this auto-nitro ni, sebab auto-nitro ni dia absorb lights kan, and then dia releasekan drugs. Okay, so when they cleave, so this is the polymer lah, polymer before cleave. And this is after the cleave. Dia dapat dua komponen. Okay. So that's why I said in the beginning, subject ni actually you applied the concept of chemistry in order to develop the smart materials. Okay. So this is another light sensitive chromophores. So if you still remember, tadi saya cakap PRP, kita boleh prepare when we have polymer plus chromophore. Dan lagi satu type adalah plus chromophore plus second element. Okay, so in this case, we can co-polymerize with polynipalm, for instance. Okay, polynipalm, because polynipalm is temperature responsive. So that means in this case you can have dual function. Okay, dual function. So bila you increase temperature dan bila you exposed to UV light, you can have the polymer that responds to the stimuli in combination. That means terhadap temperature pun dia respond, dan terhadap pH pula, terhadap light